So now let's look at questions 7 through 12. We need to find the value of x minus y over x when x is -2 and y is a -3. So this is evaluating. We need to substitute our values in. Remember, using our parentheses. So we have x minus y all being divided by x. Well, this is a negative and negative, so we are adding. -2 plus 3 is a +1, and we have a -2 hanging out in the bottom. So we have an answer of -1/2. It looks like that is A. Remember, it doesn't matter where the negative's at. Here we have the negative on the bottom. Here it has a negative with a 1. You know, it's not the specific numbers of a fraction. Really, we could write it like this, so that the whole fraction itself actually is a negative. Regardless of the case, the answer is A. Number 8, we are multiplying. We've got 3 terms of our expression here to multiply through. It doesn't matter. Multiplication is commutative, so we can, best example I can give you is, 4 times 3 times 2 will give you the same result as 2 times 3 times 4. So it doesn't matter what, order you put them in. So I'm going to go ahead and just distribute this 2 to this parenthesis first. So I'm going to distribute the 2 to the 4x and the 2. So it's going to make the first parenthesis 8x plus 4. And again, we don't have to take that 2 to each parenthesis, right? When I do 4 times 3 times 2, I don't do 4 times 3 and then 4 times 2, right? I just do the 4 times 3 and then multiply by the 2. So now we've got this kind of mess. Remember, we're multiplying by binomials, right? 2 terms. Everything has to get multiplied by everything. Right? So here we go. 8x times x is 8x squared. 8x times a -1 is a -8x. Now I've got to distribute the 4. 4 times x is +4x. +4 times a -1 is a -4. Okay, so when I expand out this binomial, I'm now left with 4 terms. Look to simplify, and I have a -8x plus a 4x, which is a -4x. So we have an 8x squared at the top. That don't have that, and that doesn't have that. This doesn't even have a middle term. So now we're looking for, which one of the 2 remaining things has a -4x in the middle. Boom, we can see B takes care of that. Number 9, looks like we're adding fractions. This was the first chapter we just got out of. Remember, you need common denominators. So we have a 5 and a 4. The LCM of 5 and 4 would be 20. Okay, so if I take the first fraction from 4 to 20, we multiplied by 5. The second fraction, we went from 5 to 20, we multiplied by 4. We're going to add across. 5 plus 4 is 9. We keep that common denominator. Look to simplify. 9 over 20 doesn't go anywhere. So that is our answer. Ooh, number 10, we got some fractions here. Honestly, what I would do, you have a calculator. I'm not going to look to clear these things. Just go ahead and use your calculator. So I'm going to add the 2/3 over. So in my calculator, I'm going to say 4 plus 2/3. You can turn it into a fraction if we want. So now we're left with the 1/3 x is equal to 14 over 3. And actually we have common denominator there with a 3. So, what times x will give you 1 times what number will give you 14. So that actually shows you the answer. If you don't see that, multiply these 1/3 times x is stuck by multiplication. So we can divide that fraction that we just got by the 1/3. And it will take us to 14. So, just like you would if this, if these weren't fractions, go ahead and solve it the same. You have a calculator, they can take care of the fractions. Don't freak out about it. This guy is pretty tough. We can add and subtract fractions when they're numbers. When they are just variables, it definitely gets a little bit it's just different here, okay? So the same thing kind of applies. We need a common denominator. What would be the LCM of x and y? Well, x doesn't have anything in common with y, and y doesn't have anything in common with x. So the only thing we're going to have here is the common denominator is going to be xy. So very similar to what we just did with this guy. We have the 5 times 4. You know, we multiplied those two numbers together. 5 times 4. The only thing is 5 times 4 gives us a numerical value of 20. When we're dealing with variables, you know, x times y is just going to have to stay x times y. Okay, so same process. To go from x to xy, we had to multiply by a y. So we're going to do the same thing with that numerator. Well, it was an r. We're going to multiply the r times a y. This fraction, we went from y to xy. Okay, so the only thing we did here was we had to multiply this guy by an x. We do the same thing with the numerator. So we have 3s. We're going to multiply that by x and say it's 3sx. Okay, so we're going to look at some of our answers here. Notice that this is an x minus y, that's an x minus y. That's not the denominator that we have. Okay, remember when we have common denominators, we're going to leave them alone. We're going to subtract. We have ry minus 3sx. Well, that has an rx. No, we wanted ry. That has an ry. That doesn't. So the only thing that makes sense there is D. And our last guy, a line with slope 3 passes through the coordinate point 0, 10. What is the y coordinate of the point on the line with an x coordinate 2? Well, first we need to put this in slope-intercept form so we can get an equation so we can substitute some stuff in. Well, they tell you that the slope is 3. And then remember the b value in your slope-intercept form, y equals mx plus b, is the y-intercept. They give you the y-intercept here, right? When x is 0. Right, when x is 0, you're on the y-axis, so they gave you the y-intercept at 10. Very similar to the problem we did before where we needed to find out what was going on when y was 0 on the x-axis. Instead of that, they want to know what's going on when x is 2. Okay, so very similar. If I want to know what's going on when x is 2, I'm going to substitute 2 in for x. 3 times 2 is 6 plus 10. Well, when x is 2, my y value is a 16.